All right. Hello, everybody. Welcome to the 11th, I think, fireside chat of the Vercel AI Accelerator. Today, we have Jeff Huber here with us from Chroma. And yeah, I'm excited for this talk. Chroma is an official partner of the Accelerator as well. They've kindly given us a bunch of free credits to try it out. And yeah, thanks so much for being here, Jeff. Take it away.
Sure. Thanks for inviting me. So yeah, I think what I'd be able to chat about today is maybe a few things. Like number one, we can do like a quick introduction to what is retrieval, what is a vector database. In some ways that's like the elementary stuff, but maybe we can cover it very briefly. Then can dive into more of a technical conversation around things like indexing algorithms. If you want to get technical, that's the way to go, probably. And then we could spend a little bit of time on like the future of retrieval. And so kind of the things that we see like coming down the pipe that we get really excited about. So maybe to start out though, to zoom out, I think that the reason that, why is retrieval important? I think is a good and valid question. And, broadly one way to think about what it means to build software with language models is that you still need to build the software. You need to write the execution path somehow. You need to give it information to tell it to do a thing. And in software 1.0 land, we would do that with code. You would write the function, type out all the characters. It would do hopefully exactly what you want it to do, even if you wrote a bug. That's how we guided the execution path of the compute. We wrote the code. With language models in the loop, there's certainly some writing of code, or you can get the language model to write code for you as well. But there's a lot of a need to steer the output of these things to make them useful, reliable, programmable, production scale, production worthy. And that comes through data. So you can either change the data the model has seen in training. That would be what we call fine tuning. Okay, thank you. I'm big. Or you can change the data the model has access to during inference, and that is what retrieval is. And so, like, this is why I think people think about retrieval as like chat your data. It's the bridge to put your data into ChatGPT, right? That's sort of like the layman's way to talk about this, and that's fine. That's valid. But I think like the sophisticated way to think about this is like we are programming by creating an environment of data that allows the execution path of a model that's doing a prompt that we've instructed it to do with real world messy information. It maximizes the chance of that being successful and, in reaching the output that we want. Like that's the sophisticated take on this is the data that you're giving the model access to is in some sense programming. So in that way, retrieval is likely for all, you think of it like a 2x2 of like no fine tuning, retrieval, no retrieval. We think at Chroma that it is likely that most production use cases will want to use retrieval in some ways. And then today it seems like some percentage of production use cases will want to use fine tuning. I think that the jury's a bit out on this. This could change as models get smaller, easier to distill, easier to fine tune, et cetera. But like certainly it seems like retrieval is like almost always important. And like obviously you can do both, right? You can do fine tuning and retrieval. Don't look at my initials. I don't know what that means. Oh, AI, I see. Okay, I get the joke now. In the chat, there was a funny comment. Okay, so that's why retrieval is important. The current tool that people are using broadly to put information into context windows dynamically is what people call a vector database. I'm sure you all have been on Hacker News enough or lived in the AI world to know what this thing is. And so don't presume to tell you anything that you already know. But the ability to use embeddings to get semantically relevant content ends up being a quite powerful tool in the information retrieval process. There are likely other powerful tools like doing text-based kind of classic text BM25-based retrieval, as well as more broad like IR pipeline stuff. So like using re-ranking and other steps. These are all things that we think are quite interesting. I'm guessing most of you have already used embeddings, OpenAI embeddings, et cetera. There are a great number of great like open source embeddings as well, embedding models. I think that one of the things that we're interested in like spending more time on at Chroma is like figuring out better eval around retrieval, so we can help people understand like questions like how should I check my document, which embedding model should I use? But some of that work is still in our future. The thing that we're spending the most time on at Chroma today is, so Chroma today has I think a pretty great in-memory and single node story. And then we're working on two things over the next couple of months. So we're working on the distributed version of Chroma, which in technical terms is a cloud native scale out database. that runs in a kind of cloud environment. Shares a lot of architecture and DNA with AWS Aurora. I can go into so much detail about that if people are interested, but maybe I'll leave it there. And then, yes, thank you, Hassan. Hosted Chroma will use distributed Chroma. So in order to run ourselves using the open source project, we're actually implementing a thread level multi-tenant application to offer serverless billing and hopefully as low as prices as possible to end developers. We needed to build something from the ground up. There's literally nothing today that you can pull off the shelf to do this. Everything else you'd have to do always on compute, or you'd have really crazy long cold starts, or you'd have kind of messy permissioning between different tenants' data, or I can go on to more and more detail. But we basically had to build something from scratch in order to offer this hosted service we want to offer. So 3 or so months is the time into that. The initial version will be serverless. So it's sort of like a pay for what you use. Son's raising his hand. I don't know if you want to say something or if that's just you're saying high five.
Both.
Okay.
I had a quick question actually. So a bunch of folks here, just for context, are actively using OpenAI embeddings in their startups and projects. And Chroma actually did do a fireside chat a couple of weeks ago where they walked us through that. So I wanted to ask, and kind of you mentioned Chroma as an in-memory database, or that you're working on that specific part of it. Can you tell us what an in-memory database is, and also how do you compare? Sorry, yes, I didn't mean Chroma. I meant I meant here, and also Pinecone actually did a talk as well. So. Yes, thank you, Sean. So my
Sean's
question
AI replica
is
specifically.
Yes, Sean's AI replica. Thank you. So my question specifically is, what's this in-memory database piece, and also how does Chroma in general differ from something like Pinecone?
Differentiation is always a fun conversation. It's obviously one we hear about a lot, and I think that we have, what I think to be some interesting or good answers to. So happy to chat about that. So Chroma, if you think about the relational database landscape, so take a OLTP transactional database, right? You have both things like SQLite, which are very lightweight and run on your local computer, or run kind of in process somewhere ephemerally. Maybe they have a persistent story to disk, but it's not meant to be a client server database, in the way Postgres is, for example. And then you have Postgres. So Chroma, our goal is to enable developers along that entire journey. So everything from pip install ChromaDB, pull it into a Python notebook, and build a little experiment inside of a Python notebook, that works just fine. Run the server on your local computer inside of Docker or directly, that works just fine. And then the idea is that the same API works in the distributed world as well. So once you've learned the API inside of the Jupyter notebook, you can use the same API all the way through to supporting tens of millions of users. So that's our goal, is to have that same API from the smallest demo or experiment all the way up to the highest scale and the most number of users. In terms of differentiation, so I mean, things are really, I think that the analogy here is that we are in the area of the Industrial Revolution, and the internal combustion engine and the Model T had not been invented yet. And so Benjamin's iPhone, yes, you will be able to run your own serverless version of Chroma, kind of. You can run the architecture. Somebody has to pay for some of the servers to be always on, right? So you'll have to pay for that part yourself. It will be open source. It will be Apache too. You can tune the paging of cold hot, so you can keep most of your indexes cold, and then only load them into hot when you need to fulfill queries, for example. So that will be So it will be serverless mostly. Not okay. Great. Thank you. Great. So in terms of differentiation, I think that we're very early. Maybe current vector search technology is equivalent to the steam engine. It's good, but it's not really the end state. And so here's a few analogies to think about. So number one, what is a vector? A vector is a point in higher dimensional space. Great, right? It's a series of numbers. That number represents a point in higher dimensional space. What is vector search? Vector search ultimately is a fast ruler to compare the distances between different points, to figure out which points are close. So points and rulers. These are the tools that we have today to analyze latent space, our points and rulers. And at Chroma, we think that you need a lot more tools, a lot more data structures, and a lot more tools than points and rulers to build a production application using embeddings, using vectors. As it turns out, as many of you have probably found the hard way, building a sexy demo using anything ML related, language models, embeddings, etc., is pretty easy, right? sexy demos tend to be quite easy, but getting the level of reliability that you want for production remains extremely difficult. This has been true about traditional deep learning as well. Sexy demos were easy and production was hard. And so we think you need to go way beyond like points and rulers to be able to build a production application. So one example, Eric says preach. Thank you, Eric. High five. So to build a production application, here's one example, is clusters. You want both clusters and clustering, right? The ability to store clusters as a concept, and then also the ability to do clustering as an algorithm, and then have like inclusion, exclusion as a way to test, like whether embeddings are inside or outside, certain regions or certain clusters. So there's a bunch more I could talk about there, but I think that like the way that we think about it is that like that's really important on kind of the classical side. And then on the ML side, it's quite likely that honestly learned representations of retrieval end up being the best in terms of recall accuracy, speed, and all of the soft, benchmarks that you care about as well. And so I don't know that vector search as a tool will be used very widely 2 years from now. Like it could genuinely be that most people 12 to 18 months from now are using a learned representation of retrieval and not cosine similarity anymore. And so, we don't really feel that like vector search is the end all be all. We care about AI memory as a company. It turns out that vector search and vector databases are a pretty important thing to get right. We think it's a building block in that larger story. But to us, it's just a part of the larger story. So hopefully that helps a little bit I can keep talking about this obviously, but I'll try to cut it off there.
That's great. That answers my question perfectly. Thank you.
So it speaks a little bit more to like kind of where this is all going. Actually, earlier today, we did a webinar thing with LangChain, where Anton, my co-founder, talked a lot about advanced retrieval schemes as well. And a lot of this is still in academia, but we think it's useful for people to be thinking about. So go check out that webinar if you want to see what Anton shared. But in high level, there's all these different ideas around how retrieval can be more tightly integrated into the loop of streaming out tokens. So for example, today, we basically have this one-shot retrieve and stream paradigm. So you have the prompt, you retrieve relevant documents, and then you stream out end tokens, and then you call it a day. And there's a bunch of research going on inside of academia where you are retrieving like every token, or you're retrieving every end tokens, or you're retrieving based on saliency. And there's a lot of just really, really interesting work. And why retrieval is so cool to us is that it's like fundamentally pretty interpretable to humans. Like if as a human, you can understand like what's inside this thing. Versus the weights of the model itself are still, pretty much a black box. So yeah, that's kind of what we're up to. Maybe some high level other stuff, like we're in SF. We're building out, yes, I will grab the link. We're in SF. We're building out a small team. We are hiring. None of you are in the market, but if any of your friends are, you should tell them to come work here. And there's more to say, but maybe I think questions and answers are more interesting than just listening to me talk. So.
Yeah. Let's move into Q&A. Anybody have any questions? Chroma also raised a pretty huge Series A.
Seed round.
Was it a seed? Yeah, it was a seed. Yeah. The amount was just like, pretty crazy. Yeah. I think it's close to $20 million seed. So congratulations for that.
Thanks. Yeah. We ended up raising like a $18 million seed round. We're sort of very privileged to be in that place. Guillermo joined as an angel, which is cool. So, okay, there's questions here in the chat. So I posted the link to the webinar. For those of you that are interested in checking that out, check that out. Eric asks, how do you think about interleaving retrieval in a context? You mentioned papers and research on every end tokens. I don't quite understand your question, Eric. Maybe you can restate it and I'll come back to it. Oh, there you're on live. Okay.
I'm online. Sorry, that wasn't super clear. So yeah, you sort of mentioned that the typical use case is one shot. You just go grab some stuff, cram it in context, and then you're good, which is essentially like alignment, not so much memory, right? So you sort of mentioned that there's some really interesting stuff on continuously retrieving as you're generating tokens, or not limiting the retrieval to just the initial system prompt or context. Can you speak to how y'all think about that? What you see? I mean, you mentioned some papers. I don't know if you know offhand. I'd love to hear just like expanding on that idea.
I just pasted a link here in the chat to a conference called ACL that just happened. And this conference was on retrieval-based language models and applications. So it's like extremely up to date. It was like a month ago. So check that out. I would encourage you to check that out. The slides are very approachable and very digestible. So if you want to learn more about like what is the state of the art for learn retrieval representations, different ways that retrieval are being integrated with language models. It's pretty great. So yeah, I can go into more detail, but that might be best to kind of just point in that direction. So cool. Okay, Jake asked for some examples of applications of Chroma. Jake, do you mean applications using Chroma, or do you mean use cases of Chroma?
Yeah, use cases.
Yeah, so I mean, the basic use case is the retrieval augmented generation, which is a fancy word for chat your data. So we like to think of this use case as like the newspapers on the internet use case. So when the internet came out, what did everybody do? We like rushed to put all of our newspapers on the internet. And like, it's sort of like, in some ways laughable because it was obvious. We're already doing newspapers. Now they're just on the internet. But also every newspaper now is on the internet. And so we think of the chat your data use case as sort of similar. It's the kind of thing where it's like, oh, we already had chatbot type stuff. We're kind of just doing chatbots in a different, better way now. It sort of just, we're already kind of doing something that we were doing before a little bit better. But we also think that like, it will be everywhere. Like every unstructured corpus of documents, likely you will want to have the ability to have natural language querying over top of it. And so on one level, it's fair to criticize it as like trivial or like played out, like, okay, yeah, sure. That was cool. That happened in LangChain 6 months ago. Check out this new cool stuff. That's like so passe. But I think on another level, it's like, no, probably most companies in the world will do, RAG-like looking things for the next 30 years at least, for most data sets. So I think that's one application is like the RAG stuff. And yes, Eric is totally right. It is actually not trivial once you get it. Yes, exactly. Beyond a demo is actually not trivial. Totally agree with that. And then other applications are, I think, still kind of, emerging and evolving themselves, right? Like you couldn't predict social media when the web came out. However, that being said, I do think that agents as a buzzword continue to be quite interesting. There are obviously like agent to agent interactions, these things like AutoGPT and maybe AGI and, whatever the heck, like agent framework tool. And those are really cool. I think that the utility has yet to be played out. It's not entirely obvious how useful they are. One thing that I'm excited to see, and there's a couple of companies working on, I think, the very first versions of this. One is Sam Whitmore and Jason. I'm blanking on his last name. Maybe Swix knows the company name. You can put it in the chat. Pretty sure Swix does know the company name. You can put it in the chat. They're working on like sort of human agent interaction. And I think this is actually extremely promising. And in broad strokes, I think the simplest way to think about it is like an email agent. So you have a little agent that lives over your email inbox, and you can give that agent natural language instructions for how to, thank you, new computer. You can give the agent natural language instructions for how to help process your email better. And so imagine something like, hey, agent, next time I get a calendaring email, do this. Hey, next time I get an email from my mom, do that. Next time I'm getting a calendar email from my mom, do this thing. I'm laughing at Swix in the chat. And that idea of having an intelligence that lives inside a piece of software that can help customize that software to your dynamic natural language instruction set, so that like human agent interaction is something that like I think is really underrated. And I think that like will be extremely commonplace, probably, under a year from now. And some of that could be, direct sort of chat style call and response as we see it today, right? But other things might be more abstract. And so, for example, Chroma ran this program recently called Hackers in Residence, where we asked a couple people to come in and build open source for a few months, build really cool stuff in open source that used Chroma and used Retrieval. So one of them, this guy, Suvanch, I'm actually putting up a video probably later today or maybe tomorrow, interview with him, where he kind of like walks through what he built and demos it and stuff, and the code is all open source. He built this thing called Claire, where Claire does things that, ChatGPT does not. So Claire remembers things about like the entities that you care about. Like my sister's name is this, her birthday is that, she's really into this. And Claire can use that entity memory when answering questions about, your sister, for example. Furthermore, Claire like can proactively go and ask you questions. So it can say, hey, I remember that like last week you told me about this. Like, how is that going? Or now that that event passed, can follow up about that kind of stuff. So I think those kinds of interaction paradigms that move beyond the call and response of like ChatGPT are also really interesting. So a bit of a hand-wavy answer. I wish that I had been to the future and could give you a more direct answer. But I think that the AI memory for agent stuff is like incredibly interesting and exciting. The one other one which I'll point to, which is more of an agent-to-agent world, is this paper called Voyager, which was implemented by this guy in a team at NVIDIA. And the idea with Voyager was that this like little agent would learn skills inside of Minecraft and would use Retrieval to help store and then retrieve those skills. So
awesome. I think Dillian had a question, and then we'll go to Benjamin's question in the chat right after.
Okay, great.
Cool, thanks. Hey, Jeff, thanks for the talk. I just had a quick question. Well, two questions. One you just recently talked about was like the technological developments in AI agents. Is there anything else like you're excited about as well in terms of like developments in the AI space?
Yeah. I'm particularly interested in open source language models. Maybe that's not really a hot take, but I am interested in open source language models. I'm interested in them not for a few reasons. So which I think are maybe more, I don't see these reasons talked about very much. So maybe this is like kind of interesting. So one reason that I'm interested in open source language models is that it can take advantage of like the latent compute that people have running on their local machines. And I think this will make it possible to run intelligence on a lot more stuff that running it in the cloud is very challenging and very costly. So, taking advantage of like, you already own a pretty good GPU and CPU, probably many of them. And most of us have like laptops coming out of our ears and probably a couple of desktops too. And so just taking advantage of that latent compute and like being able to run intelligence on it is like pretty cool. So I think that's cool about open source language models. The other thing about open source language models, which is really cool, is like you can do a lot deeper surgery. So when you think about like ways to graft retrieval like into the memory of the model, you can get much deeper than you can if you use closed source language models. And this is because the closed source language model companies have to, which are great, by the way, but they do want to prevent people from distilling out their models, right? So they do have to prevent some safeguards to like what levels you can interact with the models to prevent you from copying them or stealing them, fundamentally stealing them. You want to make the argument that they stole it in the first place, but so open source models don't have this problem, and so you can like do much deeper surgery into like where you like hook in retrieval. You can do things like steering using embeddings directly, not just text. So that's stuff that I think is like really exciting too.
Gotcha. Thank you. And one more quick thing as well. How does the performance of Chroma compare to Pinecone or like any other vector search providers right now?
Yeah, let me hit that, and then I'll go to Ben's question here in the chat.
Cool.
So performance is a few variables to care about. So one of those variables is QPS, so just like speed, latency, these sorts of things. Another one is scalability, so how large can you go? And then the other one is recall, which I'm sure is not lost on you all, but just to make it explicit, known nearest neighbor is the brute force, where you take your query vector and you compare it to every single vector that you have inside of your collection or your index. And then you have the mathematically true closest set of 10 nearest neighbors, let's say. That scales linearly, which is why people use approximate nearest neighbor search instead of just known nearest neighbor search. And approximate nearest neighbor search is approximate. So you're going to have a percentage of recall. It's not going to be perfect. And so just to give you some intuition here, if your recall is 50%, what that means is if you ask the ANN index, the approximate nearest neighbor index for 10 vectors, 5 will be in the overlapping set with the mathematical index, the mathematically correct index. That's like what recall means in this case. 50% would be half is in the overlapping set of KNN and ANN. So recall ends up mattering quite a bit because you could have just like one document that you really wanted to get. And if you miss that document, it's not great. And so in most cases, we don't care that much about speed these days because the language model takes up most of the speed. And the language model takes up a lot of time, the wall clock time. And so speed ends up not being incredibly important. And lastly, scale, it depends on your application, obviously. We find most developers have scale anywhere from 10,000 to like 5 million embeddings, typically speaking. So across those dimensions, a few notes. Number one, speed. Chroma is fast. We have a PR coming out later today, which will make Chroma 3 to 10 times faster. The distributed version will be as fast as you're willing to pay money for, basically. Scale. Chroma today handles up to reasonable size machines, a couple million vectors, a big beefy machine in the cloud, 10, 50 million vectors. Distributed Chroma, I think, can go, again, as long as you're willing to pay for it. Recall is something that a lot of developers really should care about. And Pinecone does not tell you what your recall is. And they don't tell you, so first of all, you have no idea what recall you're getting. They won't tell you, number one. Number two, I think the terms of service make it against the terms of service to benchmark what recall you're getting. So I think this is like a big point for developers is that you need to care about recall. And the graph data structures that most approximate nearest neighbor algorithms use means your recall will vary. So as you add, update, or delete vectors, your recall will actually change over time. This is another big problem with PG vector in the current implementation of IVF flat is that it's very sensitive to drift in the data domain. So as you update, add, or delete information, your recall can go down precipitously and you won't know because there's no alarm bells to tell you that this is happening. It's just it's happening and your application is slowly getting worse. And like you only can tell because users are telling you, hey, this seems bad. It seemed good yesterday. So watch out for recall. I think that does matter a lot. Okay, I'm seeing a bunch of other questions here. So Ben, resiliency, durability, etc. So one quick thing to say here is that Chroma architecturally for the distributed product takes a lot of inspiration from AWS Aurora, which uses a write-ahead logging ingestion point. We do that because we want to have a wall to give us the durability as soon as our service receives any data from the client and then can immediately act back. So we have a lot of durability in the system. In fact, we have a lot of redundant durability in the system because of the design of the distributed system. I can answer follow-up questions if that's interesting to the audience.
Actually, I have a really quick one.
Okay.
Maybe around the Chroma getting like kind of how to get started with Chroma. And I was just going through the docs real quick, which first of all, I noticed I landed in Python land first and had to switch to JavaScript. And so that got me curious. Are most of your users using the Python library versus the JavaScript one?
We have way more downloads in Python than JavaScript today.
Okay.
So we've had like 600,000 downloads of Python in the last 30 days. And I think in JavaScript, we've had maybe more like 60 or 70,000 downloads in the last 30 days.
Wow. So there's a pretty big discrepancy there.
Yeah. I think that's because, my theory of this is we have a first party, JavaScript TypeScript client, which has like really good, nice ergonomics. I think it has good ergonomics. But I find that most JavaScript developers, maybe not true at this crowd, but most JavaScript developers don't want to run a Docker container. And so that's like a pretty big gap. And so this is also why like serverless Chroma people are asking us when hosted is because they want to use the hosted thing, which makes sense. So
that makes a lot of sense. Yeah. So, okay. So getting started, I install Chroma, initialize a new Chroma client, and then it looks like I can just start creating collections right away and adding them. Right. So there's a lot of cool methods on collections as well. So this is for adding. And then after you add all the collections, you can query it. Am I on the right?
Yep.
Yeah.
Yeah. If you go to the JS docs in the sidebar, this might be like a nice overview. You go to the JS docs and then go to start with client first. So it's like create collection, delete collection, get or create, list collections. And that's
Very
it.
Cool.
And then once you have a collection object, you can add stuff, count stuff, delete stuff, get stuff, modify your collection metadata. Peek is like a convenience wrapper to like get a couple records to check it out. You can query, which is what most people do with approximate nearest neighbor indexes, right? They end up querying stuff, and then you can update or upsert.
Very cool.
All your kind of classic CRUD stuff.
Cool. So I'll get all this stuff. I'll have my collection. I can query it locally. But then if I want to actually deploy it in a production application, I'll have to go to deployment. And it looks like you're advising folks to use an EC2 instance and connect their AWS account for self-hosting.
So this is where it starts to get like more complicated, and it is what it is. We do have a CloudFormation template, which does work, and I think a lot of people do use that. But we want to make it even easier, which is why having the ability to click a button to sign up and get your API key and just go is attractive. We honestly don't really care about trying to monetize it. Like we will have to because it will cost a lot of money to not monetize it. But like we're doing it because it's what developers need, not because it makes money.
Makes sense. And then you can obviously use it with LangChain as well, which is great. Awesome. Very cool.
Yeah. Okay. A few more questions. Eric's making a good point. Are there some best practices you're seeing take shape? For example, chunk size, storing document metadata, chunking overlap. I don't know. So Eric is asking about like best practices of like chunking. And I don't think that I have enough conviction here to share anything. Yeah. It feels wrong. Like the entire approach to chunking feels wrong in the sense that like it feels so hand tuned. And obviously with hand tuned, you really don't want to hand tune things. Like you want the intelligence to do it for you. You don't want to have you playing with these like magic numbers all day. So that's my broad comment. But okay, there's some comment about PG vector. Okay, recall. Yep. Benjamin asked, why don't they want to use a Docker container because they want servers hosted? I think JavaScript developers want, the idea of running a service in production is like not attractive. And so maybe they're fully capable of, they already have Docker on the computer. They're spoiled. Exactly. Vercel ruined everybody. Thanks, Vercel. No. Yeah, I think that like it's just, even if running the Docker container locally is not a big deal, they do want to have some path to production. And if they think that they have to like run the service themselves and host it and manage it and keep it up, that it's just sort of like a non-starter, which I can certainly appreciate as a developer myself. So, yeah.
Awesome. All right. Any more questions? We still have 10 minutes if anybody has any more questions. And if not,
I've got plenty of time. I can continue to chat about anything people are interested in.
I have so many questions. So I know I've been kind of asking a lot, but if there's open space here.
I think there's open space, claim it.
Yeah, you mentioned a couple of things about clustering and some of the things that are going on after your beyond just search.
Yeah.
Similar here, you're living and breathing this every day. Are there best practices you're seeing take shape? Are there interesting directions you're seeing places go? I mean, you made pretty clear that you're not just interested in vector search, you're interested in recall more generally. So like, I'd love to hear about where you see the puck going there.
Some of the features that are, I would say, so there's a long list of features or, tools, which are perspective. They might be useful. They might not be useful. They might be useful to 5% of users, might be useful to 9% of users. We'll have to see. Then there's a list of features where it's like probably almost all users should be using these sorts of tools. And obviously those are the more interesting ones to productize. So on that list, here's a few, and some of them are specific to recall and retrieval, and some of them are more lifecycle tools. But so one of them is this idea of what we call online recall monitoring. So as I mentioned before, graphs can degrade in quality, and you don't necessarily know. And so what we want to do is, as part of the managed commercial service, have this ability to take some percentage of your production traffic and then do the brute force search and then compare it to the results from the approximate nearest neighbor search and give you a graph over time of how your recall is doing, basically. So that's one thing. Another thing is wanting to give developers better semantics over like when should they use different index types, because if you're under 10,000 embeddings, generally speaking, you should just brute force it because that's pretty fast. And then once you cross 10,000, you should start consider using an approximate nearest neighbor search process or approach. But that in some ways really shouldn't be like a thing that you manually have to change. You basically can imagine an index type that like just does it for you. And so this idea of like, you start filling up an index, you put a couple thousand in, it's just brute force. You put a couple thousand more in, we start to detect that's getting big. We build up this like approximate nearest neighbor index in the background for you. And then at a certain time, do like a 0 time cutoff from one to the other. That's kind of another like life cycle tool. Another tool is fine tuning your embedding space. And this does not mean changing the embedding model, but it means, imagine embedding space is a map, right? And you can imagine like squeezing and shrinking and, rotating and like changing the topology of that map transform of some kind. And what that allows you to do is give feedback to your embedding model to say, hey, this is a bad retrieval, this is a good retrieval. And that is factored into this transform, which then is applied over top of your embedding space. So you can look into the OpenAI cookbook. There's an example for like fine-tuning your embedding space. I think that almost all developers will use some kind of like fine-tuning your embedding space. Let's see. I mean, I think eval is a really big deal. So being able to say, doing a sweep, and this is the dream, right? And we're working on this pretty actively. Being able to say try n chunking strategies cross with n embedding models and tell me which one's the best for my data. Because ultimately it needs to be like empirical like that. You can't just, there are probably best practices, sure, but like to really be able to have conviction about like mathematically, this is the best chunking strategy and the best embedding model for my data set and my query pattern as well. It's not just about the data, right? It's also about your query pattern. because ultimately those are the pairs that go together. I think that that's also really important and very underrated. So that's kind of like a high level like list of things we're thinking about. Okay, Dylan asks a lot of questions too. Where do you see RAG going in 1 to 3 years? Yeah, I think that it'll be something more. You can look at this paper from DeepMind called Retro, which is very popular, which will probably have a learned representation versus a like kind of hard coded representation. Parallel vector search, Epsilon. Yeah, we actually looked at this and we looked at the underlying paper that Epsilon implemented. It's a paper from, I think, Alibaba. There are trade-offs. Well, confidentially, we also ran this algorithm. I won't say who it is, maybe because it's recorded. We ran the algorithm by a friend of ours who knows a lot about vector search. Put it that way. And this friend was sort of like, yeah, this has like all kinds of sharp edges that like they're not considering at all. So just, buyer beware. HNSW remains the king for a reason. I would not go elsewhere currently. So.
Cool, thank you.
Cool.
Awesome. Well, if
Cool.
there aren't
I've got
any
one
more,
more actually. If you
go for
great.
it. Well,
Please.
What's up, Jeff? Good to see you. I'm on a call, sorry. Yeah, when I was like looking at vector stores, I found that like I almost wanted just like plain old relational data also stored with like each document. So like documents were associated with, a user, or a team, or an organization or something like that. Which like led me to leaning on PG vector basically. I guess it seems to me like most use cases would like want the normal relational stuff on top of it. I wonder is that true? Does that fit into Chroma's story?
I mean, the way that people do this today inside of Chroma is we have the ability to store arbitrary metadata and metadata filtering. So you could say like user ID 4, and you could store that alongside the embedding. And you could say like, give me the embeddings that are nearest to this embedding where user ID is 4. And that's in some sense doing like the join or the filter that you really care about. It's probably a broader question, which is like how, 10 years from now, like what percentage of, workloads will be kind of in something that calls themselves more, well, we may not even call it a vector database at that point, to be totally frank. I mean, there's this joke that like all protocols eventually adopt SQL, right? So it's like, even NoSQL now, I think has SQL. I think you can like use SQL to like query Mongo. Like I think that like
and Postgres has really good like JSON semantics now too, right? Like it kind of ate Mongo in a lot of ways.
I mean, Mongo's still a $25 billion company, so I think they're doing okay. I don't think they really care about JSON column and Postgres, but I think that relational databases are obviously really cool. We use them inside of our architecture. Like we actually like use relational databases inside of the distributed architecture of Chroma to do specific roles and tasks that they're very good at. I think that like the jury's out on the exact future of how this stuff shakes out. But I think that if you are concerned about if you want to build production AI memory, I would not bet your farm on Postgres. They will always be at a minimum 2 or 3 steps behind, and 2 or 3 years behind. So.
Is that because of the like recall issue that you talked about before, or something?
Because Postgres, at best today, you can imagine if you think that vectors are points and vector search is a fast fancy ruler. Chroma has added, or sorry, not Chroma. I got distracted by the chat. PG vector is a point in a ruler, and it's actually not a very good ruler. It's kind of a bad ruler. I think the path to PG vector, and they're trying to catch up to just like baseline state of the art, like have HNSW, which is the algorithm that most people use. I think that like they will always be like a couple years behind at best. So I personally, if I was building a tool or an application, I would not build it on top of Postgres, because you need to be at the edge of what's possible, not living in the past, because that's where your alpha is as an application. So.
Cool. Good answer.
All right. Alex, did you have a question? And if you did,
Yeah.
Looks like yes. All right. We'll make that the final question and wrap up right after.
All right. Thanks. Thank you so much, Jeff. So
Sure.
if someone has built their AI application without Chroma and now they want to adopt Chroma, what would be the best way to do it, and what is the value that they would get out of it?
It depends on obviously what they're coming from. So if they're coming from doing everything in brute force, they'll get speed up.
I can make it a little more specific so you can maybe help us. So we're building this ChatGPT for code mod creation. Code mods like some code transformation bots. And right now we're using OpenAI and possibly other LLMs. Now we want to see if we have a data set of high quality code mods that we have collected, can we use Chroma to use their embedding and somehow improve the output that we have for our AI application?
Are you using a vector database today in any form?
No.
Okay. Yeah, so I think that like you can play around with this stuff kind of experimentally at first. So one thing that I think is useful to start out, if you're really just like dipping your toes into this, is like do the retrieval yourself. So take an example of query from a user, go find the relevant paragraphs of text or the relevant paragraphs of code or whatever, copy and paste them manually into the context window, like the GPT-3 playground or like the ChatGPT chatbot, the box, and compose a prompt and say like, here's the user's like question, consider the following documents when answering the question, 1, 2, 3, and then let the model go. So you can kind of like stub out retrieval yourself to get like some level of conviction that like, okay, here's the model's answers without any supporting evidence. Here's the model's output with the supporting evidence that I, human, would select. And that you can compare those. And then obviously like if there's an improvement, then maybe like retrieval is something that like you want to consider. That's like a pretty rudimentary way to go about it, but I think is totally valid. So yeah.
Got it. So it's kind of another way of improving the results of LLMs by providing relevant context.
That's right.
From the high quality data that you have from the past.
Yep, that's exactly right. So imagine there's a prompt that goes into the model, and some of the prompt has the user's direct question or the user's direct task. And then there's like this variable field inside the prompt where you can inject whatever you want, right? You can inject whatever information you think will improve the chances of the model doing the right thing. It could be information about tools. It could be information about, data, time off policies for HR, whatever you want. And so the question becomes, what should go in that box? And you only have so much room. So what should go, it's a kind of a bin packing problem. Like what things really matter to go in that box? And, usually if you have the right stuff, the answer will always be better. And so then the question becomes like, how do you design a system that always grabs the right stuff?
Got it. This is super helpful. Thank you.
My pleasure.
Yeah, I feel like that could work really well for your use case, Alex. I don't know how you're doing prompting specifically, but I know you do have a code mod for like going from the Next.js pages router to the app router. And I don't know if you're feeding it examples or doing that with the LLM or if you're fine tuning, but it seems like, the more of those conversions that you do that are also high quality, the more in the future, when you're trying to use those conversions, you can pull from not only just the Next.js specific ones, but even drill down even more with something like Chroma as a vector DB. So that sounds like a cool use case.
Super cool. Thank you so much.
Yeah.
All right. Thank you so much, Jeff. I appreciate this, man. This is great. Everybody was super engaged. Yeah. We gave you like 1 million questions and you still came through.
I appreciate it.
Thank you very much.
I had a great time. Thank you all.